my name is Balderas from Chem 120, section 413, and today we're going to talk about Le Chatelier's principle. In particular, we're going to talk about changes in concentration, volume, and temperature affect their equilibrium point. So let's get into it. So the first topic we want to cover is how changes in concentration affect their equilibrium. So in general, the way we interpret this is, if we have a component that's increased on either our product or reactant side, and a system that's already at equilibrium under given constant conditions, then the equilibrium will shift in the direction that decreases that concentration of the given element. So as we can see here, we have dinitrogen gas. And if we were to increase the concentration, then we would shift towards the right, towards our ammonia. However, if we were to decrease the concentration, then we would shift towards the left. It's also important to note that solids do not affect their equilibrium point. So the second thing we want to talk about is how changes in volume affect our equilibrium. In order to do so, we use the ideal gas law. And if we keep temperature and pressure constant, we see that volume is proportional to our number of moles. Therefore, if the volume of our system were to increase, then our system would in turn react by also increasing its moles. So as we can see here, we have dinitrogen gas and dihydrogen gas. We have 4 moles on this side and we have 2 moles of ammonia gas. So if we were to decrease our volume, then we would shift towards the right, and if we were to increase our volume, then we would shift towards the left. As an additional example, we can see that if we decrease the volume of our solution, it initially gets darker, but the system then compensates by shifting its equilibrium to the right, which is our dinitrogen tetroxide. We can visually see this since the solution gets lighter. So the last thing we want to cover is how temperature changes affect their equilibrium. And the most important thing is identifying whether the reaction is endothermic or exothermic. If the reaction is endothermic, then heat should be treated as a reactant. And if the reaction is exothermic, then heat should be treated as a product. So as we can see here, our reaction is actually endothermic because the enthalpy is positive. So given that information, heat is actually a reactant. And once we have heat as a reactant, we can just treat this as the first topic, which changes in any component is added into our system. So since we add heat, let's say, then our equilibrium would actually shift towards the right, as it would in the first situation that we covered. And if we were to decrease our temperature, then the equilibrium would actually shift towards the left. So that was a brief rundown of Le Chatelier's principles. I hope you learned something. Thank you.